This is a tutorial on how to use your calculator to graph piecewise functions. So let's start off with the first example. Here we have a function that equals negative x squared plus 4x minus 1 as long as x is less than or equal to 2. And it also equals negative 2x plus 7 whenever x is greater than 2. Now let's put this into our y equals so we could graph it. So when we do that, we'll first put in the first function as normal. So negative x squared plus 4x minus 1. Now we need to set this condition here, where x is less than or equal to 2. Now the way we do that is whenever we're done putting in this expression here, we'll just hit divide, and then in parentheses, we'll put x is less than or equal to 2. So we'll hit x, and then to get to these inequality statements, we need to get to test, this blue lettering right here above math. So to get there, we need to hit second, math. And now under this first tab, you can see a list of different inequalities or equality signs. Well, here we need less than or equal to, so we'll hit option 6. And now we put in 2, and then close the parentheses. So as of right now in our y1, we have the first expression in our piecewise function, as well as its condition, which we state at the end. Now let's put in the second expression into our y2. So we have negative 2x plus 7. Now we need to put its condition of x is greater than 2. So to do that, we'll just hit divide, and then in parentheses, put in x, and then now we need to go back to our test again, so second math, and then put in the greater than symbol, and then now 2, and then close the parentheses. So now with our y2, we have the second part of our piecewise function. We have negative 2x plus 7, and then we set the condition of x being greater than 2. So when you're doing piecewise functions on your calculator, to set the condition, you always just hit the divided button, and then in parentheses, type out the condition. So now let's graph to see what that looks like. So if you notice with our first expression from the piecewise function, it draws that part of the parabola until it gets to 2, and then it stops. And then from there, the second expression takes over and is graphed for all parts of x greater than 2. Now if you wanted to look at each part of that piecewise function individually, you could just turn the one off that you don't want to see. So for example, if we don't want to see the second part of the piecewise function, we'll just hit enter on its equal sign so that it doesn't have a black box anymore. So when we graph, we'll only see the first part of the piecewise function. And again, it'll stop at x is 2, because it won't go any further than that, because that's the condition we gave it. Now let's try one more example. So this time, we have a piecewise function with compounded conditional statements. For example, with our first part of the piecewise function, where f of x will just equal x, it has a compounded condition of x being greater than negative 5, but less than or equal to 3. So how do we put that into the calculator? Well, first of all, we'll put in x as that first part of the function, and then we'll hit the divide button as we did with the previous example. Now at this point, we can't just directly put in the statement as we see it in parentheses. If we do that, we'll come up with an incorrect graph. And I'll show you an example real quick. So right now we have the statement exactly how it's written in our piecewise function. But if we graph that, it obviously doesn't work. So we need to do something a little bit different here. So the way we put this into our calculator is we actually have to put in two separate statements at the same time. So first we could put in x is greater than negative 5. So we'll do x, and then go to test, and then put in our greater than symbol, and then type in negative 5. But now we also want x to be less than or equal to 3. So we need to specify that we want both of those conditions to happen at the same time. So what we could do is we could go back to test, and then there's the second tab called logic. Well, if we go over there, there's different statements here. Well, since we want both the conditions to work, we could hit and now put in the second part of the condition. So x is less than or equal to 3. So now we have the first part of the piecewise function, as well as both parts of its condition. So now that we've done that, we could graph it. And as you could see, it graphs the function f of x equals x between x is negative 5 and x is 3. Now you may notice that the calculator does not graph the open and closed circles on the endpoints of the piecewise function. So you'll have to keep that in mind when you're looking at this graph. All the calculator will do is just draw those line segments. So now let's proceed to do the rest of the piecewise function. So let's put in the second part. So y equals 3. And now let's put in its conditions. So the first one is x is greater than 3. So we'll type in x is greater than 3. Now it also has a second condition, so we need to put an AND statement there. So we'll go over to logic and hit enter on AND. Now we need to put x is less than or equal to 7. So we'll do x is less than or equal to 7, and then close the parentheses. And now let's put in the last statement as well before we graph again. So we'll put in the expression negative 2x plus 17. And now we want to put in its condition. So we'll start with the parentheses and then do x is greater than 7. And then close the parentheses. Now let's graph this function. As you notice, it does the rest of our piecewise function with its appropriate conditions. And that's how you graph piecewise functions on your calculator.